I'm the CEO and co-founder of SIMBA Chain. Dr. Ian Taylor, our CTO, co-founder as well. Me and Ian still talk about how we went to our first conference, and there's just the two of us, and it was in Las Vegas. It was like a couple years ago, and it was crazy because we spent it was like $7,000 to go to the trade show. Like almost all of our money that we had, in the company to just go to that. So we've grown a lot. We got 25 employees now, and great revenue stream coming in. And so it's been fun to build this company from the ground up. And we're excited to show you everyone all of our cool new Truffle integration stuff that we've built. And we're hoping that really like to hear the customer feedback and provide this tool to help all the users out there that are getting into blockchain and are really interested in it, but maybe not have all the exact skill set that you need to get it going. So SIMBA Chain tries to simplify that. So without further ado, I'm going to hand it over to Ian. He's going to really stream through our whole we're releasing a ton today. So get ready. We're going to be probably information overload. So go ahead, Ian.
Yeah, hi everyone. Great to be here at TruffleCon. I'm going to take you through a little bit of history about SIMBA Chain, and then get over to the platform and talk about what we've been up to recently. So SIMBA Chain, I met Joel as he said, well, about 4 years ago, 2016. He contacted the CRC at Notre Dame, where I was working at the time as a research professor, and suggested we put in this blockchain grant. We did that. I wasn't familiar with blockchain at the time, but I'd spent the previous 25 years in distributed computing. So, and I love the idea of decentralization. So I kind of grabbed it and wrote a proposal, and we got funded. And since then, it's been a journey, as Joel said about the conference 2 years ago, two of us, and now 3 years later, we've been awarded around 15 million in DoD contracts. We're working with NAVAIR and Air Force. We just had a conversation with DLA 10 minutes before this call. We've got multiple implementations out there. Some examples, we're working with Tokes. I'm going to talk about that a bit later. DAO and Caterpillar. And then we have an educational platform, which is interesting. We've launched this recently. We have a number of universities listed here already participating in this. And they're basically using SIMBA Chain as a graphical means and interface, a simplified interface to enable people to use blockchain. So the kind of departments, they're not really computer science, they're more business or law departments that are engaging, which is great to see. And then we're also providing course completion using digital certificates. So we've got those, and they're anchored on a blockchain, of course. So we're using BlockCerts V2 right now, but we're looking at verifiable credential version in the near future. So these are the different components. We have 12 components I'm going to talk about today as I walk through the platform. Of course, on the outset, we've got the Auth. And surrounding our platform, which was kind of the idea from the outset, is to build a model that helps us build relationships between the entities that we're looking to track. And from our backgrounds, we were very kind of interested in supply chain and parts tracking and asset tracking in more general nature. So having this model enables us to piece things together and make relationships between these different things that we're looking at. And this forms the basis of other tools in our toolkit, like the virtual APIs, for example, that we generate from smart contracts. The smart contract designer uses the model as its base, and then we also have search using, we can search that structure that we create. And I'll just go through each of these, and then we have the rest of the tools are centered around enterprise-grade tooling to make this not only simple to use, but also production strength and for enterprise applications and sustainable. So just looking at the high-level concept of SIMBA, this is a supply chain use case here. So on the left-hand side, we've got fictitious scenario with a part that needs to be delivered somewhere. It might be tracked in a number of ways. It might be tracked at a number of geographical locations. It could be tracked as it goes on board a flight to another country, and then it might be tracked on a transport to a destination. So all of those, the assets and the way that asset has been tracked throughout that journey is specified in a graph, essentially. And this is a simple case because it's one asset and multiple ways of tracking the asset. But when you get into more complex scenarios, the graph extends to kind of more complex scenario, things like, a part might have a supplier might have a reputation, and so forth. So you start building up all these different relationships. And we have tools that enable us to embed those relationships into the smart contract that we create. And it's a kind of annotation that we have in the smart contract that specifies those. But what that results in is an encoding of what the data means when it puts on the blockchain. So by the time the transactions go on chain with SIMBA, those transactions on chain have already existing relationships to other transactions. So those relationships are already recorded. And then on the outset, we can use tools then like graph querying to search those relationships. So rather than looking through the data, in a monolithic way, we can look at it using graphs and search the data that way. So if we look into the model a little bit more, and this is kind of looking at the model from the center going outwards. So the core model is based on assets and transactions. So an asset would be something you want to track. That could be a physical part. It could be a data set. It could be a token, whatever. And then a transaction would be how you track that asset. So in terms of like the supply chain use case, I gave several examples then, tracking different geographical locations and so forth. So the assets are the nouns of the business process and the transactions are the verbs. Those applications are specified at smart contract level, which form a graph. And that graph is used to auto-generate smart contracts on the back end. So I'll go through that in a little bit more in detail in the next slide, but we can take that model and we can auto-generate smart contracts. And then once those smart contracts are deployed, we can auto-generate a smart contract REST API using that model and the data that we store within that as kind of a structured backend for that. And then once that is stored, we can use search tools. So we use GraphQL to be able to search the resulting data. And this graph model is extensible. So I talked about the smart contract, but we can go beyond that. So smart contracts can relate to other smart contracts. So data that stored through one smart contract method could be related to data in another smart contract method. And that also, with SIMBA's new release, we can extend that to blockchains as well. And I'll give an example of that later. So we can have a relationship between some data that's stored on one blockchain with data that's stored on another. And that forms part of this larger graph that we can query. And we also support different versions of smart contracts. So if you think about that, you can have multiple versions of smart contracts that span different blockchains, and the entire graph is searchable, such that when you search the smart contract, the most recent one, it knows about the previous smart contract, so it automatically searches all of those as well. So you never lose data. So this is a nice sustainable kind of approach for enterprise applications. A smart contract designer, this is a low-code, zero-code approach. And when I say that, we're not attempting to kind of create smart contract logic. We're not touching that. What we're using this for is really to specify the high-level relationships between, between smart contract methods or between transactions, between assets, as we call them, and transactions. And that enables people to brainstorm and kind of create ideas about what data they want to store, especially if they're not computer scientists. They don't really want to delve into smart contracts directly. They can look at this UI and they can build up this graph and model and relationships without really kind of needing to understand the code at all. So they can do that, and then we can also upgrade to new smart contracts and languages. And the way that works is on the back end, we have a server component. The front end UI specifies the graph that specifies these relationships. On the back end, that graph is sent to the back end, and then we convert that into a binding, which would be for a particular smart contract language. So that could be Solidity, and we could easily support multiple versions of Solidity. We just import new templates for those, and we can get up and running. We have several versions of Solidity already supported in the platform. And the UI makes it really simple to build these relationships graphically to rapidly design these smart contracts. And then we've more recently, and I'm going to show this a little bit later in the talk, we have a export mode that exports those smart contracts to Truffle. So you can import into Truffle, develop those smart contracts further, then exchange back to SIMBA Chain for deployment. So smart contract designer looks like this. The red Rectangles are the assets. The ellipses are the transactions. So this is additive manufactured component. And we have a design that relates, that is used to print a component. So the component references a design. And then once the component is created, we can then create transactions that manufacture that component, deliver it, receive it, and install that component. And with this conceptual model, we click on any of these boxes and we have a pop-up that enables us to specify the parameters. And we can also click off-chain storage there at the bottom, that green, which enables us to automate the off-chain of data. And we have mechanisms for that too. And then this results in a smart contract being created. And then once we have a smart contract, we go through a simple process of deployment. So we take the first step in a four-step process is to choose the network you want to deploy to. So this is Ethereum and Circle of Life. It's our private network, but you can deploy to RSK, Ethereum, or whatever. We support several blockchains. And then the second phase is to choose the off-chain data system that we support. So IPFS I've chosen here. The third is to choose a smart contract. So we pick a smart contract for this deployment. And then the last phase is to choose the app name and the API name that results in a URL that you talk to. And that feeds in. Once that smart contract is deployed, we then create this virtual API for it. So this is a developer interface, which is more familiar with developers that are not fluent in blockchain. So it's more for general consumption. And the way this works is that the smart contract methods are exposed as REST endpoints, and we create get and post methods for those that can post to the blockchain and access the blockchain. And the benefits of this is simple, well-known interface, help developers integrate with blockchain into enterprise applications. And the APIs are custom for an application. It's not like we're standing up an API to connect to a blockchain where you have to do everything yourself. These APIs are specific to the smart contract methods and the data payloads, and they come fully documented as well. So you have a complete documentation of your smart contract and what you're talking to specifically within the methods of those smart contracts. And another kind of, on a logistical point of view, that these APIs are completely virtual. There's no code that exists here. This is automatically generated based on the endpoint the application goes to. So we don't need to, on the back end, manage multiple source codes and understand how to scale that. This can be managed within a single instance, which makes it extremely scalable. And the APIs are fully documented. So this is, we provide Swagger interfaces. You can click on these, you can click try it out. You can, post to the blockchain, create a transaction right from the interface that's provided. And we're also supporting redoc as well. So there's multiple ways of accessing this now. And then in terms of the, the post kind of HTTP point, what do we do there? Well, we have various levels that try and attempt to make the platform as resilient as possible to, issues that can arise, right? So the first thing we do is we validate transaction syntax. So the parameters in the payloads, are they going to actually take, or are they going to result in an error? So we have multiple, checkers there that support that. And then we also manage and load balance transactions, which include nonces. And this becomes resilient to peak loads. So the validation piece, this ensures the payload is valid. So we automatically fix minor errors so that they can continue when it's obvious what the payload meant. And then we will return major ones before posting to the blockchain, so it doesn't result in extra kind of processing there. And then we also have intelligent nonce management to ensure that using distributed locking and caching, that ensures this goes through. And this diagram on the right hand side here, this just kind of shows what happens in a flow. So you have an application talking to a HTTP API on the top left of that diagram. That goes into a queue. The queue, basically, each transaction that comes in, the queue transacts it, and it waits. It kicks off a blockchain process, a Blockm process rather, that monitors that transaction until it gets a receipt. So we, in the queue, we cache the transaction in the database, but it's not in a database, but we don't enable that. It's not valid at that point until the Blockm application verifies the receipt as it's been published, and then we transform the state into the cache DB, which we'll talk about in a second, which provides access to the search capabilities of the application. In fact, you can You can search using the cache, or you can search the blockchain directly. The cache is just a kind of, maintains consistency with the blockchain, as we talk about in the next slide. So this transaction cache, its purpose is really to cache the blockchain transactions in a database to make the lightning fast search, really, as opposed to blockchain data. And the way that is implemented, we have a 24/7 process that monitors the transaction state. It can monitor the states as they go into the blockchain, or it can do it retrospectively and catch up and check for consistency. So it's running all the time doing those kind of things. And it checks the state submitted, transitional states pending, reverted, and finalizes with either completed, failed, or timeout. So we're monitoring all of those. And then once it's completed, we cache to a Postgres database, which includes some metadata in a table and JSON payloads for the actual blockchain transactions themselves. And then in terms of the blockchains, we have multiple blockchain bindings. We have this abstraction adapter pattern. So there's no dependency on a single blockchain. You can move from one to another very seamlessly among the supported blockchains. And also support multiple blockchains per application as well, as I touched upon earlier, and I'll get back to that in a second. But in terms of the blockchains we support, we have a generic API to Ethereum, Consensus Quorum, Hyperledger Fabric, Binance, Burrow, RSK, and Stellar. Right now, Stellar is the outlier there. It's a very different approach, and we did that to kind of prove the concept of these adapters, whether they could handle a very different blockchain that handles flows rather than kind of smart contracts that are more kind of static in that sense. But it's pretty straightforward to add others to the platform. Binance, for example, we added, it was just a matter of a day or so to get that binding kind of integrated. And then the graph relationships between those can link across chains. So one example we've done recently is in the DoD for Naver. We have two blockchains integrated in that we've got a Consensus Quorum blockchain integrated within the DoD. And that is completely private. Only they can access that network. It basically contains maintenance, repair, overhaul data for tracking parts internally. And then we have an OEM blockchain which connects to different OEM manufacturers. And that is a shared ledger between the DoD and the different OEMs that are participating. And that ledger is actually Hyperledger Fabric using the Burrow EVM. And we're connecting those two together seamlessly in an application, and we're essentially connecting them across at the part level. And we're using a cage code for a supplier, essentially to map and connect those two systems together using our graph relationship. So Naver, so the DoD in this case, can query across both of those ledgers to look at for an MRO process for a particular part from the kind of aircraft status. They can map down right down to the parts that constitute the assembly of that particular process, right through to the OEMs that are supplying it. And they can see that within a single graph query if they choose to configure it that way. We have search and access API, so developer web APIs for transaction cache and a blockchain. This provides two searches, really. It provides a mechanism for searching endpoints, so either smart contracts or methods. And we also have a mechanism for searching relationships. So the first enables application-oriented targeted searches. So you can basically query, do a get on an endpoint of a method, and that will retrieve all of the transactions from that method, or you can filter those transactions using one of the search mechanisms we provide for that. And then we can also do GraphQL, and I'll talk about the GraphQL a little bit later. And then we also support off-chain data. I won't spend too much time on this, but essentially we support off-chain by having bindings to multiple file systems. We have IPF, Ceph, Azure Blob Storage right now, but we have other bindings in that are coming up as we roll out implementations. The way that works is essentially we take a hash of the off-chain data and store it on-chain in the simple case, but we also support bundles. So in the bundle case, at the bottom of this slide, we can have multiple files, and those multiple files get stored in an external file system. We can generate hashes for those. We can take those hashes and put them in a manifest file. That manifest file has information about each of the files and their hashes, and then we can hash the manifest store that in the file system, and store the resulting hash on chain. And that makes it simple, so posting multiple files to a web endpoint, a REST endpoint, when you post a transaction, will automatically take all of those files and put them in that file system in that format. And when you do a get on that, you can retrieve all those files too. So it's a very simple way, of managing that process. And then transaction subscription. So every transaction that is posted through SIMBA Chain, you can subscribe to it. You can also filter subscriptions by parameters, support multiple targets. So we support SMS right now using Twilio, and we support email and web notifications. And we can configure those endpoints, so you can put in usernames, passwords for your SMTP server and things like that. And then we can also add filters. So you can say things like, monitor this transaction for my part, for a particular part, and then say only notify me if the ID is 8756 and the name is Ian, for example. So you can do things like that. So that can trigger those notifications essentially to feed into other applications or to notify users. The Auth, we support authentication and authorization within enterprise environments specifically. We've also been looking at, in terms of authorization, how to bind to different other platforms. But we have Auth0 in the app.simbachain.com, which is the public version of our platform. And then in the enterprise, we have Azure Active Directory full integration there, including auto-generation of wallets, if you choose to do that, to bind to the Active Directory identities. And then we also have DoD Common Access Card authentication, which we added recently for our DoD projects. You have to, anybody in the DoD uses a Common Access Card to access data, so you need to provide that support. And then we also have multiple SDKs in Python, Java, Node, and .NET. This is an example on the right here that just basically uses a Node SDK to send a signed data payload to a method on a smart contract hosted using Quorum. So this is a very simple way of interfacing with the REST APIs, from the client side. So there's support for that in various languages. And then the dashboard. So on the dashboard side of things, we have a dashboard on our public website, which you can go and sign up to now at app.simbachain.com. And then what we're showing here is the enterprise version. This provides more advanced searches using the GraphQL and so forth. So it has a smart contract designer, which is here on the bottom right hand side. So you can create smart contracts using zero code GUI approach, which we have on app.simbachain.com as well. You can deploy smart contracts on any supported blockchain. So Quorum, for example, we use in many of our applications. You can manage your subscriptions and filters for those, manage organizations and users. So we can have organizations, have applications and organizations, and application is the basis for deploying smart contracts, and you can deploy multiple smart contracts per application. And then you can configure the authorization. The authorization is configured at the smart contract level, so you can give people in Active Directory groups, for example, access to certain smart contract methods and configure those. And then we have interactive and visual blockchain transaction queries. So if we go to this, the GraphQL interface is an example I put together. So on the left, we have a graph that shows a supplier part, which results in that supplier part object essentially connects multiple things together, connects a supplier with a part, and it also connects that to a price and a non-conforming part abstraction that we identify if we find that certain parts have been non-conformant in the past. And then the part connects to something at the top, which we call extra detail. Now, the way this works is if you click on the supplier part here, then this is what you get. You get these different colors. The green here on the first level means that they're selectable because they have direct relationships. The second layer, the orange here, that means they might be selected depending on what you select next. So if you select supplier next, you wouldn't get that, right? But if you select part next, which is what I do here, then I'm able to go through to the next level and access that next layer of the graph and the relationships therein. So on the right-hand side here, I show how that works. So I've selected supplier part, and the part detail, which is F1, F2, F3 here. And then I've specified on the right, you get a UI for each of those that enable you to filter the parameters. So which parameters do you want from those transactions? And also to filter by specific rules, right? So I've said here, that the part number contains 43. And then on the bottom, this is another kind of filtering mechanism for the next thing, and so on. So you can configure your query completely at every level, and you can choose where you want to go in the data and what you want to extract using this graph. And then you just click go, and you get the first level back, the supplier part. And then each of those will have a relationship with something else. So in this case, the part. So you click through the part, go to the F2 level, and this will be the part level. And then the part detail, you can click on that to click through to the actual detail of that particular part. And then the Truffle integration, the purpose of this is really, from SIMBA's perspective, is to be an expert mode. So we don't, we're not providing kind of a UI to create code within smart contract methods. What Truffle is excellent at doing. So we've integrated that, for that purpose. And from a Truffle user perspective, this would be a way of using the SIMBA tool. So you can use SIMBA to deploy smart contracts and visualize them. You can use SIMBA to take Truffle smart contracts and deploy them onto any of the supported blockchains that SIMBA provides. And then you can also use that to generate a smart contract API that can be used for the application integration. And this gives you full access to the SIMBA Chain environment, which already supports enterprise, infrastructure, and including working within the DoD. So this is a little demo that we put together here.
So if I go back here just real quick and show you, we have a list of contracts. We don't have a toy contract yet. So this is the new one that we want to deploy. And first, as with every Truffle project, you need to compile your Solidity so that it creates a build artifact. So we're going to do that first. And hopefully it succeeds. Okay, so you can see it created the toy build contract. And the next thing I want to do now is just export that to the platform. So I'm going to type SIMBA run. Truffle run SIMBA export. And what this should do is give me an option of contracts that I want to deploy. I'm going to select our new one, which is the toy. And that's going to send that to the SIMBA platform. Now, if I go back to the platform and I refresh, what we should see now is our new toy contract. We can view that code here. Okay, so we have a toy contract, but it's not deployed to an application yet. So if I go to my app, you can see that we don't have the last one deployed was a coffee shop transaction. So to deploy, the next thing we're going to do is we're going to type Truffle run SIMBA deploy. And we've already selected our primary contract in the previous step. So we know the Truffle plugin knows which contract to deploy. Now it's just looking for a name. So we're going to call this Toy Shop. We're going to deploy to Ganache using our local storage. We don't have any constructor arguments, so we're going to skip that. And it deploys using our platform. And it was deployed to address 2C37. So now if I go back and I refresh my screen for the application, we should see there's my Toy Shop API, there's my toy contract, and we can see it was deployed to 2C37. And then from here, what we can do is just, it's deployed, so now it's ready to be used. So if I were to click on the API, we should see in the list of list of contracts we have, we should see Toy Shop, and here we see Toy Shop, and we can see.
Oh, so that shows you how to deploy contracts. I wanted to just touch on this. We're running out of time, so this is a project that we're doing with a Mexican restaurant chain that has about 230 restaurants across Mexico, and they're already promote sustainability. This video on the right here is when we visited them last year, and we went to visit the farmers in Tacana, and they've already stripped back the supply chain from about 10 to 4 entities and increased the revenue to these farmers by a factor of 2. There were 21 families living on around $15,000 a year before. And now through their sustainability practices, they're able to double that. And we're looking at ways of helping them, providing clarity to this process so that they can claim this sustainability. They've been reluctant to do that so far because most people do not believe those claims unless they're proven. So blockchain comes in, perfect here as a way to kind of prove that to the public. This is an application we use that we've implemented. This application is used at the co-op, and it's used to provide, register the beans as they come in from the farmer. So if you look at the workflow on the left, so the farmer brings in the beans, it goes to the cooperative registers the beans, we bring her into the app, we generate a QR code, and we track that on the blockchain, and then it goes to the desheller to deshell the coffee, and then back from the desheller. And then once it comes back from the desheller, all of these transactions are recorded on the blockchain. It goes to the roaster in Mexico City. It gets to Mexico City, they scan the QR code, that transaction goes to the blockchain, and then it goes into the WMS system. And we've integrated with that also, so those transactions are also going to the blockchain throughout the whole pipeline. And the benefits of this approach is that, for the first time, the coffee beans are actually tracked from the farms to the Turkish restaurants. Counterfeit coffee cannot be exchanged for the Takana coffee. Only Takana coffee can be sold as such. And it enables new business models. So we're already in this pilot that we're just launching in a couple of weeks' time. We're differentiating between good and best coffee for the first time. And that enables monetization of the best coffee to a higher price. And that money is going directly back to the farmers to enable them to be more sustainable in the future. And then the last couple of slides, we won some awards. Last year, we won the Best New Product of the Year in Indiana. And we also won the Commercialization Award out of Notre Dame. And then we also recently won the gold medal at the Additive Manufacturing Olympics, which was great because in the final it was Stratasys and Boeing and SIMBA Chain, and we got gold. So thank you very much for your time. And this is our team that is growing by the day at the moment. Thank you very much.
Thanks, Truffle. Thanks, Tim, Dave, and Wes.
Thank you both. I got to tell you, it's so exciting for me when I watch a presentation and I get to see Truffle being used, and the way that you're using our plugins and actually working with SIMBA Chain. That was really exciting. Thank you both. And it's actually really exciting to see all the things that you're doing, again, out in the real world. So thanks, Joel and Ian.